In this lecture, we are going to introduce to the concept of pointers in C. Now, pointers is one of the most important topic in C programming, which is very often misunderstood by many students or many beginner programmers. Now, pointer is the most powerful concept which gives power to C programming, and this is the reason why C programming is quite popular. C programming is popular because of this powerful concept of pointers. So in this lecture, we are going to try to learn pointers in a simplified way. So let's get started. So first of all, let's try to see what is a pointer. Pointer is nothing but it is an address of a memory location. It's an address. Pointer is an address. So whenever you create a variable, let's say you create a variable int a equals to 5. Now this variable would be stored in the computer's memory. So whenever I say computer's memory, I'm meaning the primary memory or the RAM, random access memory. Okay, so this variable a would be stored in the RAM. Now RAM would be capable of holding this variable a. So it will create a space in the memory to store this variable a. Let's say this is the portion of the RAM. Now in this RAM, whenever I write a equals to 5, the operating system will decide in which location this variable a needs to be stored in the memory, right? So let's say this a is stored in this yellow box, and name of this box will now be called as a, and this box is going to have a unique address. Okay, now this is the address. 101 is the address of this box. So we say this 101 is the pointer. It is the address of this box. So each box or each memory cell in the memory is going to have a unique address. Okay, so whenever you create a variable, it is going to be stored in the memory, and that memory is going to have the unique address, and that address is fixed. Okay, now this address in the memory which is fixed can be related to the plot of land in the real world. Okay, so let's say this is a big piece of land which is divided into different plots. So these are different plots. In some of the plots there are houses built. Okay, now these are the plot of land. Now each of this plot is fixed. Its location is fixed. That means its address is fixed. In this plot you can actually have your building created. You can build your building, right? In each of these plots the buildings can be created. Now these buildings are nothing but the content of this plot. Like for example, this variable a is having the fixed address 101. Similarly, this plot is having the fixed address that will not be changed. You can't actually take this plot away and place it somewhere else. The land is fixed, right? So the address is fixed. But inside this address, you can store different values. Like for example, inside a, in this example, I have stored the value 5. Okay, I can also very well do a equals to 6. In that case, now this 5 would be replaced by 6. Now this 5 would be overwritten and it will be replaced by 6. Although the space is same, but now I have got the different value in this space. Similarly, although I have got this building built here, I can actually, destroy or demolish this building and create a new building in this particular plot. That is allowed. So you can think this plot of a land as the address in the memory which is fixed. Now let's try to do the comparison between the plot of a land and the memory. Okay, so this is the land that's given, that is shown to you, and this is the computer's memory divided into different cells, different units. Like this big land is divided into different plots like this. Okay, and this memory cell is now divided into different units like this. Okay, now each portion of the land is called as a plot. Okay, this each portion is called as a plot. This is a plot. Okay, similarly, each portion, each part of the memory is called as a memory cell. Okay, memory cell. So these are memory cells. What is the size of each plot? Now size of each plot in the real world can be of a variable size. Okay, now all the plots can be of different sizes. See, this plot is quite smaller than this plot. Okay, all these plots can be of different sizes or variable sizes, but in the computer's memory, each memory cell is of the fixed size. Okay, it's of the fixed size. Okay, and generally each of these memory cell is exactly 1 byte long. Okay, each of these memory cell is having exactly 1 byte long. Okay, now let's talk about the address. The address, what is the address of each plot? Address of each plot is always fixed, right? Address is never going to be changed. Address of each plot, the location of each plot of land is always fixed. Okay, similarly, the address of each memory cell is also fixed. Okay, and each byte or each memory cell is going to have a unique address. Like each plot is going to have its unique address. Similarly, each memory cell is going to have the unique address, and that address can be a number. Okay, let's say the address of the first cell is 100. So what would be the address of next cell? It would be 101. All cells will be sequentially arranged in the computer's memory. So this is 102, this is 103, this is 104, this is 105, this is 106. All these are addresses of memory cells, and they come sequential. The memory cells are arranged in the sequential order. That is, they come one after the another. Okay, so address is fixed in case of the plot and also in case of the memory cell. What is the content? What is the content of the land? What you can have inside this plot? That is the content. You can have a building, right? You can have a building inside this plot. You can have your farm. You can have your house. You can build so many different structures in that plot. Okay. Similarly, what can you have inside this particular boxes in the memory cell are the values you can have. You can store the values. You can store the value of a variable, right? Even you can store the address of some other variable. You can actually store something here that is called as a value. Okay, so the content of each memory cell is a value. Okay, so I hope this is clear. And these addresses, whatever is there of memory cell and the address of a plot, this is called as a pointer. Always remember that pointer is nothing but the address. Address of what? Address of a memory cell. So all these addresses are pointers. Okay, so whenever we are learning about pointers, we need to keep few things in our mind. That is, whenever you create a variable, let's say I create a variable a equals to 5. Whenever I create a variable, we have to note the following things. We have to note what is the name of the variable, what is the size of the variable, what is the address of the variable, and what is the content of the variable. Okay, so whenever I say a, okay, int a equals to 5, now this is the layout of the computer's memory. Now the operating system of your computer will decide on which location, on which address, on which space your variable 5 would be stored. Okay, now let's say that a is going to be stored in this particular block of memory. It is occupying 4 bytes. Okay, starting from the address 112 to 115. Okay, so because integer is 4 bytes, integer is 4 bytes long, I'm assuming that integer is 4 bytes in my case. It can also be 2 bytes. Okay, so it is actually occupying these 4 bytes for me. It is reserving these 4 bytes for storing the variable a, and this block is named as a. Okay, and inside this box you are going to store 5. The value 5 is going to be stored. Now 5 is not going to be stored as a numeric decimal 5. It will be stored as the binary 5. Okay, so it will be 101 at the end, and it will have all zeros appending to the left of 101. Okay, so this is like 4 bytes is nothing but 32 bits. Out of 32 bits, 3 bits are 101 at the end and 29 bits are 0. So this is how it is going to be stored. This is 5. So 5 is stored here. Okay, so what is the name of this variable? What is the name of this particular memory location? The name of this entire memory location, that is highlighted yellow in color, is a. What is the size? How many bytes are allocated for a? Now a is of 4 bytes long. Okay, 4 bytes long. A is of 4 bytes long, so the size is 4. What is the address of a? Now a is allocated this memory starting from address 112 to 115. So 112 the first byte, 113 the address of the second byte, 114 address of the third byte, and 115 the address of the last byte. So we say the address is 112. We only write the starting address, right? Because once we know 112, because we know there are 4 bytes, so we can easily note down that if it is 112 the starting address, 112 would be the starting address, 113 would be the second one, 114 and 115. And we'll be taking 4 bytes because the size of integer is 4 bytes, that is known to us. So whenever I say address, I mean it is the starting address of this entire block. So the starting address is 112. Okay, now these addresses are fixed in the memory. Okay, and where is this variable going to be allocated? That's decided by the operating system. Okay, here we are assuming that operating system has stored this variable a starting from address 112. Okay, now what is the content? What is stored inside this particular block? The content of this entire block is 5. 5 is being stored in this particular block. Okay, similarly, let's say I create one variable b. Now let's say b is allocated this particular space highlighted green in color whose address is 110. Because B is of type character, character is 1 byte long, so this is just one box, one memory cell is allocated for B. Name of this memory cell is B, and inside this the content is X, so X is stored here. Okay, so let's write down what is the name of this particular memory cell. The name of this memory cell is B. What is the size of this memory cell? It is just one memory cell. So one memory cell is 1 byte. So this is 1 byte long. Okay, so what is the address of this memory cell? This is just 1 byte. It will have one address, that is 110 in this case. 110 is the address. Okay, what is the content? What is stored inside this address? The content here is the character X. So this is how the variable is stored in the computer's memory. Now we are coming to something called as a pointer variable. Okay, so to understand pointer variable, first of all, let's create a variable B, which is of character type, which is having X stored in it. So B is a character, so 1 byte will be occupied. So B is a character, so 1 byte is occupied. The address, let's assume it is 110. So this memory cell is nothing but variable B. Okay, this is B. Now in this variable B, X is stored, so the content is X and the address of this variable is 110. Now I want to create something called as a pointer variable. Now pointer variable is a variable that is going to store the address. Now this is a normal variable. B is a normal variable. It's a character variable. It is going to store the character. Now pointer variable is going to store the address of our memory location. Okay. So how to create a pointer variable? Now I would like to store the address 110, that is address of B, to some other variable. So let me create a pointer variable of type character. So I say CHARPB. If I just said CHARPB, this becomes a normal character variable. If I want to make this as a pointer variable, I have to write star just before the variable name. So if I write char star pb, this will create a pointer variable. Okay, so this is, let's say, pb pointer variable, and it is going to occupy some space. Now pointer variable, what is the size of pointer variable? How big is the pointer variable? It generally depends on which computer you are working on. It depends on the computer's architecture. If your computer is 64-bit long, it is going to have 64-bit as the size of the pointer variable. 64-bit is nothing but 8 bytes. Or if your system is a 32-bit system, it will be of 4 bytes or of 32 bits. So pointer size of the pointer can be either 4 bytes or 8 bytes. Okay, so let's say I create a pointer variable pb. Name of the variable is pb. What is the type of this variable? It is the pointer. Pointer to whom? Pointer to a character. It is pointing to a character variable. Okay, I would want this pb to store the address of X, which is 110. Okay, so the type is pointer to the character. What is the size? It can be either 4 bytes or 8 bytes. Okay, so in my case, I'm assumed that it is a 4 byte, so it is occupying 4 bytes, 4 memory cells, 127, 128, 129 and 130. So I'm assuming that my pointer variable, the size of the pointer is 4 bytes. Okay, it can vary from computer to computer. It can also be 8 bytes. Okay, now what is the address of this pointer variable? Let's say pointer variable here, starting address is 127, the address is 127. Now the very important point, what is the content? What is stored in this pointer variable? As of now, nothing is stored, right? As of now, I have not assigned any value to this pointer variable. Now the content of this pointer variable is very important. The content of the pointer variable is the address of some other variable, because it is a pointer variable, right? It will store the address of some other variable. In this case, pb will store the address of b. How do I get the address of b? Address of b is very simple. I'll write %b. If I write %b, I'll get the address of b. What is %b? %b is nothing but 110. 110 is the address of b. So 110 would be stored in pb. So inside this, 110 would be stored. Okay, so here address 110 is stored. Okay, so the content of the pointer variable is always the address. That is what is very important. So I say pb is a pointer and pb is pointing to the variable b. So I say pb is a pointer, it's a pointer variable. It is pointing to B, so I say B is a pointee. Okay, so pointer points to a pointee. A very important thing to note down here, the content of a normal variable like the character variable is the value, the character value, but content of a pointer variable is always the address of some memory location. Okay, so it is storing the address of B, which is 110 in this case. And one more very important point to note down, whenever you are creating a pointer, you have to always use this asterisk star. Okay, so you have to write char star pb. Now pb becomes the pointer variable, meaning it is capable of storing the address of a memory location. Now let's try to see how we can display all these values in our terminal using printf statement. Okay, so first of all, the same example, a character B is created which is having x stored in it. So B is having x stored in it. The address of B is 110, has highlighted here. And PB is a pointer which is having the address of B. So PB is a pointer which is having the address of B. So we say PB is a pointer and B is a pointee. So I say PB points to pointee. So PB points to the pointee B. Okay, so this is demonstrated here. Now let's say first of all I would like to display the size of the character variable. What is the size of character? It's very simple. I can just write printf %d. I am printing the size, so I'll write size of, I'm printing the size of what? Size of B. So size of B would nothing but 1. So it will display 1 as the answer. Now how do I display the address of B? Now address of B is very simple. I can write %B. Ampersand will give you the address. So ampersand is the address of operator. It will always provide you the address of a variable. Similarly, how do I print the size of the pointer? It's very simple. I'll just write printf %d. I'll have to print the size. So I'll write size of operator. Size of what? I'm printing the size of PB. PB is my pointer variable. So I just write PB here. So it will print me the size of the pointer. In our case, pointer is of 4 bytes long as demonstrated here. It can be very well be of 8 bytes. So in this case, it is 4 bytes. So it will display 4 as the answer. Similarly, how do I display the address of the pointer variable? Address of the pointer variable here is 127. To display this, I'll just write address of PB. %PB, that means address of which variable? Pointer variable PB. So I'll write %PB. Okay. Now how do I display the content? How do I display this X? B is storing the value X, right? B is storing the value X. How do I display this X? It's very simple. I just have to provide the name of the variable. I write printf %C because the format specifier is %C for character. It is storing the character. So I have to use the format specifier for character. Format specifier for the character is %C. So I'll write %C, printf %C and provide the name of the variable. Name of the variable is B. So whenever I write B, it will print the character X. So it will display X. Okay. Now, how do I print this address 110? Now, 110 is nothing but the content. It's a content of the pointer variable. So, to display the content, it's very simple. First of all, I have to use the format specifier for this content. So, I'm displaying the address. This is the address. So, what is the format specifier for address? The format specifier for address is %P. So, you have to write %P notation to print the pointer or the address. You can also use integer, that will also work fine, but %P is the better format specifier to be used for displaying the address. It will display the address in the hexadecimal notation. Okay, so I write %P and then here what do I provide? I have to provide the name of the variable. What is the name of the variable? PB. So whenever you are going to display the content of a variable, just provide the name of the variable. In this case, see, in this case to display X, I just provide the name of the variable B. Similarly, here I'd like to display 110, which is the content of this pointer variable, right? So to do that, I'll just write the format specifier %P and the name of the variable PB. So it will display 110. Now, before we end this lecture, we'll discuss a very important concept that is related to pointer. Okay. Now here PB is a pointer which is storing the address of B. Now PB, this is PB, which is storing 110, which is nothing but the address of B. Now my question is, can we actually catch hold of this value X by using the variable PB? Okay, because PB is already storing the address of B. So using PB, can I get to this X? If I just print PB, it is going to display 110 because the content of PB is 110. But if I want to go to X using PB, what I have to do is I have to use something called as indirection operator. The indirection operator is nothing but star. Indirection operator is nothing but star. So whenever in a pointer variable I put star, so if I write star PB, what it is going to do is it's going to see what is there in PB first of all. In PB there is 110. So star will take it to this address 110. So it will go to this address 110. Here this is the address 110. And then it will find the content of this address. So content of this address 110 is X. So star PB would be X. Okay. So by using the asterisk, that is the indirection operator. Now asterisks have two meanings. Okay. You can use asterisk or the indirection operator to create a pointer variable like this. While creating a pointer variable, I can use star, the same asterisk. Okay. Once the pointer variable is created, okay, star acts like a magical stick. So if I just put star in this PB, which is the pointer variable, it will go to the address that PB has stored. So the address that PB has stored in this case is 110. It will go to 110 and catch hold of the value inside 110, which is X. So it will display X. So this is how you can actually catch hold of the content that the pointer is pointing to. Okay. So here the content that the pointer is pointing to is X, which is nothing but the value inside the address 110. You can use asterisk to get that value. Now one more thing before we end this lecture. In this case, I'm storing the address of B in the pointer variable PB. Okay. Now there must be compatibility. I can't just write it as int star P. It will not work. If I want to store the address of the character, I have to have a character pointer. If I want to store the address of an integer, I have to have an integer pointer. So in this example, I'm storing the address of a character, so I have to have this as a character pointer and not as an integer pointer. In case you would like to store the address of a float, you have to have a float pointer. Let's say you are having a float variable, float x is equals to 12.3. I would like to have a pointer storing the address of this variable x, so I'll have to have a float pointer. I'll have to write float star px pointer to x equals to ampersand x. Okay. Now this is all right. Now they are compatible. So if you have to store the address of a float, you have to have a float pointer. But all this pointer, whether it's a float pointer, whether it's a character pointer, whether it's an integer pointer, all of them, all this pointer is having the same size. It is either 4 bytes or 8 bytes. Okay. So this is the basics of pointer. I hope you understood how pointer works. In our next lecture, we are going to write our own program to demonstrate the working of pointers.